See, we were discussing about shallow foundation and bearing capacity of shallow foundation. See, if you see the syllabus, okay, see this is your syllabus, semester 5, third year, okay. Now what we are discussing, this part we are discussing soil mechanics 2, subject is soil mechanics 2, and we are discussing about this part, module 4 we are discussing this part. And you, if you notice, almost we are completing this discussion, almost. See, just let us try to understand the syllabus first, then syllabus wise whether we have discussed or not, let us see. See, bearing capacity we have discussed, definition, then factors affecting bearing capacity, then modes of failures. What are the modes of failures? Remember, general shear failure, general
Yes,
shear,
sir. General shear failure.
correct, general shear, local shear, and punching
Local
shear.
shear, yes, sir.
We have
Yes.
discussed
Okay.
everything, right? Methods of determining bearing capacity of soil. How do you determine? Terzaghi's bearing capacity theory, right? Terzaghi's bearing capacity theory. Then effect of depth of embedment, eccentricity of load, foundation shape on bearing capacity. Foundation shape, eccentricity we have discussed. Only part left is depth of embedment, okay. Then effect of 11, I don't know why 11 is written somewhere mistake. Effect of water table we have discussed. Then eccentric loads we have discussed. Then isolated footing with combined action of loads and moments. See, you remember combined action of loads and moments we have discussed, where we have discussed that when there is a point load and when there is a horizontal load, then there will be some moment getting created on the footing, and because of the moment getting created on the footing, what will happen? There will be some eccentricity will be coming, where we can find out the eccentricity by just dividing the moment with the what? Moment with the
Yes,
vertical
sir.
load.
Effective length और breadth निकालते थे.
हाँ, so then effective length and breadth will compute, correct. Then we'll
Yes.
using the effective length and breadth we will be calculating the bearing capacity equation, okay.
सर
हाँ, बोलो बोलो.
सर दो तीन चीज में प्रॉब्लम था.
हाँ, problem discuss, let us discuss first, let us discuss the issues whatever you have, then we'll start. बोलो.
सर वो जब लोकल शेयर फेल्योर होता है
Yes.
सर, तो उसमें इंटरपोलेटिंग से कैसे निकालते सर, एनसी डैश एनक्यू
हाँ,
डैश?
करेक्ट, एक प्रॉब्लम दिया है ना, और बोला है कि मंडे तक
हाँ.
करो, ऐसे है ना. तो वो मेरा
हाँ.
प्लान में है आज डिस्कस करने का, ठीक है, इसीलिए मैं मंडे तक करने के लिए बोला, ओके. सी, आई थिंक कॉलेज फाउंडेशन, जस्ट you are talking about this problem, right? This one, a 2-meter wide strip footing is founded at a depth of 1.5 meter below the ground level in a homogeneous soil of bed having angle of internal friction as 25 degree and cohesion as 50 kilonewton per meter square. Bulk unit weight of soil is this. Determine the ultimate net shape bearing capacity of the footing. Adopt factor of safety 3. Use Terzaghi's bearing capacity equation. See, same problem we have solved it. We have discussed it, right? For general shear failure. If you remember, same kind of problem we have solved in the class, where the PDF document, scan copy of the some problems I have sent you. From there we have discussed one problem. It is the similar problem, but here you see, the problem says the angle of internal friction is 25 degree. Okay, so if the angle of internal friction is 25 degree, then which kind of shear failure it will be? Tell me. It will be which kind of shear failure? Bolo. No one.
Local shear failure.
Local
So
shear.
local
local.
failure.
Yeah.
Yes, local shear failure, because you see we have defined it, right? While we have discussed about the local shear and general shear, if you remember this slide, if you remember, see this slide, okay? So we have said that greater equal to 36 degree generally means general shear failure, and less than 29 degree means local shear failure. If the failure is, if the angle of internal friction is in between 29 36, then there may be a mixed mode of failure, or we may assume a particular failure and then design the footing or calculate the bearing capacity. So as you have seen in this problem, the the angle of internal friction is 25 degree, isn't it? It is 25 degree. So when the angle of internal friction is 25 degree, so the problem obviously becomes a problem of local shear failure. So when there is a local shear failure, what does the equation say? What does Terzaghi says? Terzaghi says that if there is a local shear failure, what you will have to do? You will have to change your cohesion to the mobilized cohesion, and you will have to change your angle of internal friction first to the mobilized angle of internal friction. So considering that, first you will have to change these two. So first what you will have to do, you will have to calculate the value of this phi m. Okay. So what it is saying? It is saying basically, it is saying, if you remember, at the end somewhere we are doing it. So you remember this formula, this one. So I am just going above and writing it here. So see, you remember this one, tan phi m is equal to 2/3 tan phi. So what will be phi m? Phi m will be tan inverse of 2/3 tan phi. So you now tell me what will be the value of phi m in this case? Tell me, anyone? What will be the value of phi m? So what will be value of phi m? Control V. Phi m is going to be
17.23.
phi m is going to be, bolo, is equal to
17.23.
tan inverse, then what we will do, 2 by 3, 2 by 3, 2 by 3, and then tan of 25. Okay, tan 25. If you do this and then you find out the value, so then you will be getting what is the value of phi m. So everyone is clear on this? So tan 25, you first calculate tan 25, then make 2/3 of it, 2 by 3 of tan 25, okay? Then you inverse it. So if you inverse it, you will obviously notice that value will be lesser than 25. It will not be 25, okay? Value will be lesser than 25. Clear or not clear? Bolo. Is it clear? So
Clear, sir.
Yes, sir.
So the value of phi m, what is the calculated value you said? 17.23.
23, sir. 17.23.
Okay, 17.23 degree. Okay, so you got the value as 17.23 degree. I am writing in this degree. Okay, so
Clear, sir.
you have calculated the value of mobilized angle of internal friction. Okay, that's all. Now see, in this problem what it is being said, use Terzaghi's bearing capacity equation. Use Terzaghi's bearing capacity equation. Okay, so Terzaghi's bearing capacity factors you will have to use. Now for time being, let's say for time being, you see in the PPT, if you see Terzaghi's bearing capacity factors I have given you. See in this Terzaghi's bearing capacity factors, whatever Terzaghi's bearing capacity factors, that has been given in this table. Okay, now you see in this, from this table, what may happen? See, the value of the mobilized angle of internal friction is 17 degree, and I told you that if you see Indian Standard Code table, in the Indian Standard Code table, have you observed one thing? That values are not given for every 1 degree. It is given for every 5 degree. I will go and show you. Okay, so if you remember table number 1, This table, you remember this table? So this is bearing capacity factor as per Indian Standard Code. This is bearing capacity factor as per Indian Standard Code. You observe. So what is the value given for phi? So value for phi's are given for, see, every 5 degree, 0 degree, 5 degree, 10 degree, 15 degree, 20 degree, like that. So this may be the case for Terzaghi also. So if you get a chart for Terzaghi's table, for which you, let's say, you get value of what is called NC, NQ, N gamma for 15 degree and 20 degree. So let's say you know the value of 15 degree and you know the value of 20 degree. Okay. So let's say for 15 degree for Terzaghi, what are the values you see? For 15 degree, what are the values? 12.86, 4.45, 1.52. So let's write these values. Okay. Let's write these values. So where are my NC, NQ, N gamma? So these are my NC, NQ, N gamma. Okay. So let's write it like this, then you will be clear on this understanding. Very important. Okay. So what is this? For NC, NQ, N gamma, for 15 degree, what are the values? 12.86, 4.45. So values are, let us write it here, 12.86. Then NQ is how much? 4.45, right? 4.45. So it is 4.45. And what is the value of N gamma?
Sir,
N gamma is 1.52. Okay.
sir 7.
बोलो 1 point.
हेलो सर.
हाँ,
सर बोल रहे हैं सर 17 के लिए ना लिखेंगे सर.
just a minute. Just a minute. So what I am saying, for 15 degree, these are the values, right? Just hold on. Let me explain. Okay. Let's say in this table only the values are given for 15 degree and 20 degree. 17 डिग्री के लिए दिया नहीं है. आप सोचिए, आर यू गेटिंग? Yuanshu, are you getting?
Yes sir.
See the values, see Indian standard code देखिए, Indian standard code what it is giving. Is it giving it for 17 degree? Every 1 degree it is giving? No.
No sir.
So it is
No sir.
see this table whatever I have shared with you, Terzaghi has generally computed for every 1 degree, okay? But you will not get these values everywhere available.
Yes sir, I have.
हाँ, बोलो. Yes, बोलो. So let's take for 15 degree the values are 12.86, 4.45, 1.52, and for 20 degree you see values are what? 17.69. So for 20 degree, you see for 20 degree the values are what? The values are, let's write the values, then we will see how to interpolate. So for 20 degree the values are given as 17.69, 17.69, 17.69, then NQ value is given as 7.44. So NQ value is given as 7.44, and let's see N gamma value is given as 3.64. okay, so 3.63. so is it clear now? So let's say these two values are given to you for 15 degree and 20 degree, these values are given to you. Now how do you calculate the values for 17.23 degree? That is the question, right? That is the understanding problem. So for this I have said you may require interpolation. That's what I have said. You may require interpolation, and this interpolation means here you will have to just linearly interpolate. So linear interpolation means what? So for difference in 20 degree to 15 degree, so for 5 degree difference, so for 5 degree difference, how much is the difference in value for NC? First you find out. So how much is the, for 20 to 5 degree, 20 minus 15 is equal to 5 degree difference in difference का बनान गलत दिख रहा है। Oh, दो बार difference for 5 degree difference in NC value is how much? Tell me, what will be the difference in value?
4.83.
Let's not write 4.83. For understanding, let us write 17.69 minus 12.86. Is it clear? So how much is it? 4.83. This value is 4.83.
Yes, sir.
Yes. So this difference is
4.84.
4.8. Is it clear now? Okay. So you just put it in unitary method. So for 1 degree difference, so for 1 degree difference in NC value will be how much? Bolo? Difference in NC value will be how much? For 5
Sir,
degree
4.83 divided by 5.
Yes, very good. So very good. A very simple thing, just unitary method. So how much is it? Tell me the value. 4.83 divided by 5.
0.966.
0.966. Is it okay? Okay. Now you tell me what is the value you require to calculate? You require to calculate for 17.23 degree, right? 17.23 degree, for 17.23 degree you need to calculate. So you know this 17.23 will remain in between this 15 and 20. So for 15 degree you have a value of 12.86. For 20 degree you value of a 17.69. So for every 1 degree difference you have a difference in value is 0.966. So in this case, from 15 degree to 17.23 degree, that means how much is the difference? So 17.23 minus 15 is equal to how much it will be? 2.23 degree difference in NC value is. So how much will be the difference? Can anyone tell me? So what will be the difference in NC value? Bolo?
Sir, 0.966 into 2.23.
Yes, 0.966 into 2.23. How much is the value?
2.155.
2.155. Okay, everyone is getting. If anyone is not yet getting, tell me. Very simple. Then so for this difference you are getting the difference, please understand. So 2.23 degree, this difference very important, huh? For this difference you are getting difference in NC value, and that difference is 2.155, right? This difference is 2.155. So for 15 degree what was the value? 15 degree the value was 12.86. 15 degree the value was 12.86. So for 17.23 degree, so for 17.23 degree the value of NC will be how much? The value of NC will be whatever is the value for 15 degree, and that to that you should add up this difference value, that is 2.155. That is 2.155. Is it clear? So how much will be the value? Tell me. 12.86 plus 2.155.
15.015.
15.015. Okay. So this is the value of NC. For what? For this 17.23 degree. The value of NC for for 17.23 degree is going to be this one. Is it clear? So this way you will have to find out the value of NQ, you will have to find out the value of N gamma. And when you are saying this is the value of NC, see, you should not say this is NC, because what Indian Standard Code or Terzaghi has said, you just changed it to NC dash, because NC dash, why you are saying NC dash? Why? Because in this case what you are doing, you are changing the value of NC and you are considering it for the local shear failure. So when you are considering it for local shear failure, you should write your NC value as NC dash, because in the formula you will be putting the changed values of NC dash, NQ dash, N gamma dash. Is this clear? So exactly the same way we have calculated NC dash, you will have to calculate NQ dash value, N gamma dash value. Am I able to clear this linear interpolation thing to everyone? See, very important for local shear failure problem. Okay. Now once you have done with it, then you just put the formula for local shear failure. Okay. So what is the formula for local shear failure? So the formula for local shear failure, if you remember, it is nothing but this is the net ultimate bearing capacity. This is net ultimate. So what is the formula? So the formula is this one for local shear failure, right? So 2/3 NC dash, then NQ dash, then N gamma dash. Okay. So this 2/3 will come because your mobilized cohesion. So the value of cohesion, whatever is given, this 50 needs to be multiplied in this equation by 2/3, because this is actually your 2/3 C is nothing but your CM, that is the mobilized cohesion value. So 2/3 NC dash, NQ dash here, and N gamma dash. And how do you get all these values? This NC dash, NQ dash, N gamma dash you will be getting after changing this angle of internal friction to mobilized angle of internal friction, and for that mobilized angle of internal friction you should find out what are the values for bearing capacity factors. And if interpolation is required, you just do the interpolation and find out the bearing capacity factor values, and those changed bearing capacity factor values, when you are considering the local shear failure, they will be termed with a dash factor, that is NC dash, NQ dash, N gamma dash. I think if you understand this much, then there is no problem at all in solving a pure general shear failure problem and a pure local shear failure problem. There is nothing else. Okay. Now to this problem, now I have given this problem for a split footing. Okay. Now if this problem is given for a rectangular footing, then what will happen? Shape factor will be introduced into the equation. If this problem is given for a circular footing, different shape factor will be introduced into this equation. If this problem is given along with a water table, presence of water table, okay, so then what will happen? You will have to apply the water table correction factor as we have discussed earlier, that is RW1 and RW2. If this footing is eccentrically loaded, then what you will have to do? You will have to change the effective length and effective breadth of the footing, and then accordingly apply the formula. But conceptually, the bearing capacity equation and the formulation for solving, finding out the bearing capacities will exactly remain same for general shear failure and local shear failure. Only there is a change, that in case of local shear failure, you will have to change your angle of internal friction to mobilized angle of internal friction, and for that mobilized angle of internal friction you should find out the bearing capacity factors, which will be termed as NC dash, NQ dash and N gamma dash. Is there any doubt? If you still have any doubt, please tell me.
Yes, sir.
Clear?
Hello.
Or still doubt is there? Bolo.
Hello.
Yes, yes. Hello.
Sir, sir, then why we can't take for phi is equal to 17.23 direct value of NC, NQ and N gamma?
17.23 direct, you don't have it in the table. Where is it? You see, you go to Indian Standard Code. Is there value given for 17.23? From where you will get? You tell me. Value is given
No,
for
sir, in PPT.
PPT. Here, here also where it is given for 17.23? You tell me. It is given for 17 degree and it is given for 18 degree. It is not given for 17.23 degree. Right? So for finding out for 17.23 degree also you will have to interpolate. There will be small change. In this case there will be small change, but you will have to find out. Correct? So
Yes, sir.
exact value you may not get. See, that is what I am saying. That this in this PPT I have given you the values for every 1 degree from Terzaghis chart. Okay, but not always you will be having this chart available in your hand. Let's say instead of this, let's say I change this problem. I tell you just instead of this problem, here I have written use Terzaghis bearing capacity equations. That's what I have written. Instead of this I write use Indian Standard Code IS 6403 method for bearing capacity equation. 6304 bearing capacity equation. Use IS 6403 bearing capacity equation. Or I write use Indian Standard Code procedure. Or I write Indian Standard Code procedure. Then what you will do? So Indian Standard Code procedure, as soon as I am writing, then you see you will have to use this Indian Standard Code. So in this Indian Standard Code, do you have any value available for 17.23? So you have values available for 15 degree. You have values available for 20 degree. So what you will have to do? You will have to find in between values for 17.23, and you will have to do it with linear interpolation. And for after linear interpolation, what you will have to do? You will have to replace those values as NC dash, NQ dash, N gamma dash. Is it clear?
Yes, sir. Sir,
Huh.
sir, in interpolation we only find the difference.
Interpolation. Yes. See
First,
difference. Huh. Bolo?
sir, first we find 5 degree difference, then 1 degree,
Yes.
and then 2 degree, and after that adding on to the 17.23 degree.
Yes. So why you have to add it for 15 degree you have some value, right? For 20
Yes.
degree you have some value. So for every 1 degree change, for 16 degree what will be the value? 12.86 plus this 2.15 plus this 9.966. For 17 degree what will be the value? 2.86 plus 0.966 plus 0.966. Will it not be? For 15
Yes, sir.
degree the value is this much. So for every 1 degree change, so for 16 degree what will be the value? You tell me. See, this is what we are doing. Directly we are doing. For 16 degree what will be the value? For 16 degree what will be the value? For 16 degree the value will be this, plus for 1 degree change we know what is the change. So the value will be 0.966. Correct? For 17 degree, now if I write, for 17 degree what will be the value? Bolo? For 17 degree, whatever will be the value for 16 degree, to that I will have to add plus 0.966. Is it clear now?
Yes, sir.
So this is what is interpolation. So for every value, see, ऐसे नहीं होना चाहिए that you just do it for NC and don't forget about other two. NQ and N gamma you are not doing. No, you cannot do that. Every value of, I have just shown you for NC. So you will have to do it for every value. NC, for NC also you will have to do it same way, NQ also you will have to do it same way, N gamma also you will have to do it in same way. So see, you will have to practice it. So very simple, it is nothing but taking the difference, dividing by the angle, then what is there, with that difference you multiply and then add up with the initial value, that's all. So
Sir,
if you practice once
Sir.
twice, then it will be very simple. Yes.
सर एक बार उसको वापस से प्लीज एक बार और रिपीट करिए ना.
See
कुछ
which one you want me to repeat?
सर 17.23 के लिए जैसे 15 और 20 डिग्री लिए, उसके बाद जो इंटरपोलेशन कर रहे हैं इसको एक बार थोड़ा सा रिपीट करिए ना.
See, difference in angle for 5 degree difference in angle. What is the difference? This value minus this value. That's what we have done. So for 5 degree angle difference, 5 degree difference in internal angle friction, the difference of value of NC is 4.83. For 1 degree difference, what is the value difference? So 4.83 divided by 5. So for 1 degree there is a difference of 0.966. And what value exactly we will have to find out? We will have to find it out for 17.23 degree. So 17.23 degree is how much bigger than 15 degree? It is bigger than bigger than 2.23 degree. So 17.23 minus 15 degree. So this is actually 2.23 degree. So for 2.23 degree difference, what will be the difference in NC? Difference in NC will be for every 1 degree difference. For every 1 degree difference, we have found out the difference is 0.966. So for 2.23 degree difference, it will be 0.966 multiplied by 2.23. So that value is coming to be 2.155. Now see, this is the difference. This is the difference because of 2.23 degree. Now from where we have started? We have started from this 15 degree. So at 15 degree, what is the value? 12.26. So to this 12.26, if I add up this 2.155, I am going to get the value for NC, which will be actually NC dash for 17.23 degree. So for 17.23 degree, the value will be 12.86 plus this 2.155. So it will be 15.015. Is it clear? See,
Yes, sir.
you will have to practice it. You will have to practice it. One or two problem. See, the problem I have given in the quiz, you practice it. You do it your own. Okay. Then only you will be able to understand. ऐसे नहीं किसी दोस्त से ले लिया और आंसर लिख दिया, ऐसे नहीं करना है. ठीक है. So please don't do that. You do it your own. Let it be wrong. Okay, no problem. But you do it your own. Then only idea will be clear. So should I proceed? So local shear problem, local shear understanding is clear to everyone. If you have any doubt, please tell me. Otherwise, I will proceed to the next thing. Okay. So see, I was discussing about the syllabus. So let's go back to the syllabus again. So see, bearing capacity. So almost we are closing down on bearing capacity. Okay. This 6403 discussion we are doing. So how to find out bearing capacity as per IS 6403. That is what we are doing. Hopefully another 1 or 2 classes we will be able to complete it. Then what we will do? We will be moving to this module 1. Okay, this consolidation of soil. I think consolidation of soil you have studied it, right? Consolidation of soil you have studied it in your 4th semester course. 4th semester you have studied consolidation of soil.
Yes, a little bit.
Not little bit, many things were there. Okay, so what we will do, will in detail we will discuss about this consolidation of soil. Okay, because consolidation chapter is a very important chapter. Okay, so what we will do, we will take up the theoretical discussion on consolidation of soil. Okay, see what I am saying. First we will complete this bearing capacity as per IS 6403. Maybe tomorrow we will complete the theoretical part. Okay, then what we will do, we will start with theoretical discussion on this consolidation of soil. Okay, and in one class, 2 classes we are having weekly. So in one class we will discuss the theory of consolidation, and in one class we will continue with some more problem of bearing capacity. Okay, so that way we will progress. Okay, so after this consolidation of soil is complete, then only we will go to this settlement analysis of soil. Then only we will go to the settlement analysis of soil. Okay, is it clear? Because settlement analysis of soil is totally related to the consolidation of soil. So after we finish consolidation of soil, we will discuss about settlement analysis of soil. We will discuss codal provision, everything, every detail we will discuss. See, these chapters are very important. Okay, from interview perspective, or for job perspective, or for any competitive exam perspective, be it GATE or be it your different public service commission exams, everything, every minute points we will be discussing during this foundation engineering or soil mechanics course. Everything is very, very important. Please remember it. Whatever I will be sharing with you, please study it well. Okay, go through the PPT, go through the problems, try your own. See, you will be able to solve many things. It's not very difficult. Okay, very simple. Okay, so let us today further discuss about Indian Standard Code. We will not be able to finish it today. Maybe tomorrow we will be able to finish it. So we were here, if you remember, we have discussed about the strip footing case for Indian Standard Code, and somewhere we are here at the bottom, let's say in the Word document. See, we are here, right? In the last class we have left here that in case of general shear failure we have three factors. You remember I spoken about these three factors: shape factor, inclination factor, and depth factor. Okay, and then there is a water table factor, that is W dash. Okay, and in case of local shear failure also you have shape factor, inclination factor, and depth factor. Okay, now you will have to see what the code is saying about this what the Indian Standard Code 6403 is saying about the shape of footing, effect of inclination of load, and effect of depth of embedment. So all these things are given in this code. If you notice, and if it is given also in the presentation also, whatever I have shared with you, see in the presentation also, you notice, you will observe these values are given. See, I have tried to give you the details here in this way. So Indian Standard Code 6403 1981 recommendations, if you see, for shape factor, depth factor, inclination factor, and effect of water table, then you should refer to clause 5.1.1.1, page number 8, table number 2. For shape factors, so the shape factors, you see in the table number 1, what is given? Table number 1, the bearing capacity factor values are given. So in the table number 2, if you go to table number 2, you will get the values of the shape factors. So let us see. So if you go to table number 2, see, this is actually table number 2. So all of you can see it. So see, this is the table number 2. So in this table number 2, if you observe, in the table number 2, in the table number 2, if you observe, the shape factor values are given. So see, these shape factor values, if you see, they are little different from Terzaghis shape factor values. So whenever you solve the problem of bearing capacity, you should be very careful and cautious about which bearing capacity equation you are using, whether it is asked that you use Terzaghis bearing capacity, or whether it is asked that you solve it using Indian Standard Code procedure. You should be very, very careful about it. Okay, so you see the shape factor values are given in table 2, and you notice for strip footing, what will be the shape factor values? See, in case of Terzaghi also we have seen these values were 1, 1 and 1, because the assumption of Terzaghi's bearing capacity or any other bearing capacity equation is that the footing is shallow and the footing is a strip footing. So for a strip footing, the value of shape factors will remain 1. Now for a rectangular footing, you notice the value of SC, SQ, S gamma will be this way: 1 plus 0.2 B by L for SC, 1 plus 0.2 B by L for SQ, and 1 minus 0.4 B by L for S gamma. If you remember, if you go back to Terzaghi, then you see the SQ values were 1 for every case, isn't it? The value of SQ, I will just go back and show you the difference. See, this is actually Terzaghi, this is actually Terzaghi shape factors, you see. So you see, in case of Terzaghi, for every footing, for strip footing, square footing, circular footing, rectangular footing, the values of SQs were 1. However, you notice in case of Indian Standard Code, the SQs are having some values. Only for continuous strip footing the SQ value is 1. Other than that, for rectangular footing, circular footing, square footing, everywhere it has got some value. So for square and rectangular, you see the value is 1.2. For the SC value for square and rectangular is 1.3. Only difference you notice for square and rectangular is here. It is 0.8. S gamma value is 0.8 for square, and S gamma value is 0.6 for circular footing. You will have to remember these values and formulas. There is no other way. Shape factor values you must remember, okay? And in competitive exam also, this shape factor, with this shape factor you will have to solve different problems. So shape factor values needs to be remembered, okay? And it's very simple to remember. You see, just for square and circular it is 1.3, 1.3, then 1.2, 1.2. Only difference is there is 0.8 and 0.6. And in case of rectangular, you see 1 plus 0.2 B by L, same value, 1 plus 0.2 B by L, 1 plus 0.2 B by L, and the S gamma value is 1 minus 0.4 B by L. So this is about all about shape factor, okay? So if it is a continuous strip footing, you use SC value, SC, SQ, S gamma value as 1. If it is not a continuous footing, you use according to the shape of the footing, the shape factor value from Indian Standard Code. Now next is your so next is for shape factor we have discussed. Then next 5.1.1.2 page number 5 for depth factors, the values for depth factors, you see it is given in 5.1.1.2, okay? And you will observe these values for depth factors, whatever I have written over here also, these values, if you go there in the code also you will notice it same way. So you see DC, DQ, D gamma. If you notice in the next page only the values for depth factors are given, depth factor values are given, you see these are the depth factor values, and you observe the depth factor values that is DC, DQ and D gamma. If you observe very carefully, you observe it. See, for DC the value is constant, that is 1 plus 0.2 df by b root over of n phi. What is n phi? You remember what is n phi, root over of n phi? From soil mechanics, strength of materials, soil mechanics shear strength. You remember what is the value of n phi? This is not NC, NQ, N gamma. Please understand. कोई बोल सकता है what is the value of n phi? Tan square 45 degree plus 5 by 2. Don't remember? Anyone? See this value of n phi, okay? So root over of n phi. So you please go back to your soil mechanics book and find out what is the value of n phi. N phi will be equal to tan square 45 degree plus 5 by 2. I think whatever Sayantan sir is also discussing, you will notice in the in the Rankine's theory also these values will be coming again and again. This tan square 45
yes,
degree
sir, बताए थे, sir.
Yes. So n phi is tan square 45 degree plus phi by 2. Okay. So once you know the phi, you can put the value of this n phi. You know what is the depth of the footing, you know what is the breadth of the footing, so you can calculate the value of DC. Now you observe one thing, this dq d gamma value, you observe this is given for two different zones. So if the value of phi is less than 10 degree, that means soil is almost cohesive in nature, that means the soil is not much sandy in nature. Okay, angle of internal friction is very less. In that case, this dq and d gamma factor, Indian Standard Code is saying it can be taken as 1. This dq d gamma factor can be taken as 1. However, if the value of phi is greater than 10 degree, that means when the soil is becoming more kind of sandy, or the soil is having more angle of internal friction, in such case you observe that this dq and d gamma value is not 1. To it, another one factor is being added, and if you notice, see, it's very simple to remember, don't get confused. See, in this case DC value, you see it is given 0.2 df by b root over of n phi. In this case, you see dq d gamma, you see this 0.2 only has become 0.1, and it is just 0.1 df by b root over of n phi. See, this term is remaining same, only the coefficient value, here it is 0.2, here it is becoming 0.1, and n phi value I have already explained you what is the value of n phi. Okay. So see, this correction is to be applied only when backfilling is done with proper compaction. You should remember this very well. Okay. So if the soil is backfilled, that means after you excavate the soil, okay, after you excavate the soil, any case of foundation construction, if you remember, or if you see that you will have to excavate the soil. Without excavating soil, you cannot construct foundations, right? So once you excavate the soil, after excavating, you will have to put the soil inside it, right? On that trench, again you will have to fill up the soil, right, after construction of the foundation. So when you fill up the soil inside it, at that time, if you have done proper compaction, that means if you compact the soil well inside that by the side of that foundation by filling some material or soil, then only you apply the depth correction factor. And if you observe what actually depth correction factor will introduce, this depth correction factor will basically introduce little amount of increase in bearing capacity. Okay. Now next is your inclination factor. So what are the two factors we have already discussed? We have discussed about shape factor and we have discussed about depth of embedment. So we have discussed about this SC, SQ, S gamma, and we have discussed about DC, DQ and D gamma. What we have said, this value of DC will be something 1 plus 0.1 root over of df by b into root over of n phi, and DC dq d gamma value will be equal to 1 in case phi is less than 10 degree. However, if phi is greater than 10 degree, in that case the value will be how much? 1 plus 0.1 df by b root over of n phi. Sorry, I think I have said DC value as 0.1 df by b root over of n phi. It will be 0.2 df by b root over of n phi. Okay. So is it clear? So see, very simple thing. So only you will have to multiply with some factors SC, SQ, S gamma, DC, DQ, D gamma. Okay. Next is your inclination factor. So what is inclination factor? Inclination factor, you please try to understand it. Inclination factor, I will go to this diagram and show you inclination factor. Let's say this is the footing. Now you see, suppose this is the axis of the footing. Let's say this is the axis of the column, right? So centrally this way, this column is axis. Now if there is a load, let's say acting in the footing in this way, so this is called what? This is called inclined load. What I will call it? Inclined load. So if I just increase it, this thing, and just change the color, so it will be clear to you. So you see this, so this load, you see, this is the inclined load. Okay, so when the inclined load, see, when this is acting like this, then what will happen? This is actually concentrically acting along the column axis, right? Sorry. So if this load is acting concentrically at the column level, then you see the value of your these factors, the IC, IQ and I gamma, this IC, IQ, I gamma, these values are going to be equal to 1. So in that case, you see, if the load is acting vertically on the column, then you see you need not to apply this IC, IQ, I gamma factor. That means your IC, IQ, I gamma, all these factor will become equal to 1. However, you observe, when the load is acting not vertically, it is acting somehow inclined to it. So when it is acting somehow inclined to the column axis, in that case you will have to find out the value of inclination factor. So the inclination factor, as the code defines, is given as, you see, in the code only, Ujjwal Anand, should I admit?
Yes, sir.
Okay. See, this is the inclined load acting. Now this inclination, you see, it is let's say this is your horizontal and this is your vertical. Okay, so this is your x, this is your y. Now what the code is defining, try to understand it. So you see the code just at the next page is giving this clause number 1.2.3, the inclination factors are defined, and the inclination factor, you see, it is given as IC equal to IQ is equal to 1 minus alpha by 90 whole squared, and I gamma is given as 1 minus alpha by phi bracket whole square. Okay. Now what is this alpha? That is very important. What is this alpha? So what is this alpha? If you want to see what is alpha, you will have to go back to the definition in the code. Okay, but for simplicity, you see this alpha, when this value can become 1. So see, when this value of alpha will become 90, what will happen? So if it is becoming 90, then what will happen? You tell me. So 90 by 90 will be what? 1. 1 minus 1, what it will be? 1 minus 1, 0. So if alpha becomes 90 degree, then IC, IQ becomes equal to 0, isn't it? If alpha becomes 90 degree, then IC, IQ becomes equal to 0. So you see, if you see the definition of alpha, I will go back and show you in the code only, then it will be clear. So from which direction, first thing, whether we will be measuring alpha from here or whether we will be measuring alpha from here. That means, what I am trying to say, whether we will be measuring alpha from here on this direction, means from here to here, or we will be measuring, sorry, this is not working, let me show you from the code. See the definition of alpha, we are going back. Okay, see in the at the initial part of the code, that all the values were defined, right? So there only we should be able to find what is alpha. So see, Alpha value is given or not here? Symbols A, B, C, D. Alpha is not given here. No, alpha is not given. See n phi. Have you noticed n phi? What is the value of n phi?
सर
Yes.
है सर, है
सर
नीचे है सर।
Alpha
उमेश
is
को
the
एडमिट कर लीजिए सर।
एक मिनट admit Sudhanshu Ranjan. Okay, I have done it. Okay, see the definitions. See the definitions at the bottom. It is there. Okay, see up to sorry. So see n phi, what I have told you, tan square 45 degree plus 5 by 2. Is it clear? Now you see, go down, somewhere it will be given. Alpha is given here. So see what is said, inclination of the load to the vertical in degrees. This is very important. Okay. So inclination of the load to the vertical in degrees. That means, please remember this. This is very important. I tell you, in competitive exams like GATE, engineering service, only it is being confused with this alpha value. The questions are given to confuse you in this alpha value. Okay. So what is being given, what the code is saying, the alpha is the inclination of the load to the vertical in degrees. So basically if you go to this, so this is your vertical axis. So alpha is basically this angle. You understand? Alpha is basically this angle. So that means the horizontal angle.
सर ऐड उमेश कुमार दत्ता सर।
Add Umesh Kumar Datta. How do
Yes,
I add?
sir.
It's not coming.
Sir, he is messaging me network problem.
How can I add him? I don't know.
Okay, sir, I am telling him.
I see here details are not coming, na?
Yes, sir.
He has left the meeting, right? Means बंद हो गया उसका क्या? हाँ आया
Yes, sir.
coming.
Okay.
I added. So let me take the attendance. Huh? Let me take take the attendance. Then we will continue. Google Meet attendance. 32 क्यों आया? 33 होना चाहिए ना? Google Meet attendance collector. Refresh. Let's take it again. Google Meet attendance collector. 32 is coming. 32 download. Okay. Anyway. Okay. So see, alpha. You understood what is alpha? Alpha is basically the angle from the vertical direction. That means you see alpha is, how do I show it? Is, if I take this, then it will do. See, alpha is nothing but this one. Why it is not coming? Basically this angle you are getting this inside angle. If you have doubt, please tell. Alpha is this angle. Okay, it is not this one. This angle from here to here. So you see, if the angle, if the load is given, that inclination is with the vertical 30 degree, then you directly put the value of alpha as 30 degree. Are you getting? But if it is said that inclination of load with the horizontal is 30 degree, let's say the load is inclined to the horizontal, in the horizontal direction the inclination of load is the 30 degree. In that case, what will be the value of alpha? Alpha value will be 90 minus 30. That means you will have to put, in this equation you will have to put 60 degree, because in the code the definition of alpha is inclination of the load to the vertical in degrees. Are you clear on this? Actually what happens generally in the problem, what is given to confuse, the inclination of the load with the horizontal is given, and directly generally what we do the mistake, we just directly put, let's say the load is inclined to horizontal for 30 degree, then generally by general mistake we do, we just put the value of alpha here 30 degree. So that is incorrect, because the alpha definition wise, the value of alpha is the inclination of the load with the vertical. So if the horizontal inclination, if is 30 degree from here to here, if it is 30 degree, then from here to here, the vertical angle, vertical inclination of the load will be 90 degree minus 30 degree. So it will be equal to 60 degree. So that way you will have to put the value. Is it clear? So I think this, if you understand this factor, then water table correction factor you need not to understand from here. Whatever I have discussed, whatever water table correction factor I have discussed for RW2, if you understand RW2, this RW2 and this W dash are exactly same. This RW2 and W dash are exactly same. You need not get confused with this reading over here. Okay. So RW2 dash, if you remember this water table correction factor when we have discussed, this RW2 and the W dash is exactly same as we have discussed earlier. Okay. Okay. And for RW1, what I have said, see in the codal formula, in the code formula, if you see the formula in the code, as I have mentioned you in the previous class also, you remember, only to this B gamma n gamma, this factor, this water table correction factor is multiplied. However, you see into this factor, this D gamma D factor, this Q value, no RW is being multiplied. So there is no RW1 factor multiplied over here. So what you have to do in such case, either you use RW1 factor and reduce the value of gamma, or you use exact value of gamma above the base of the footing. Why the code is being done, code has done it in this way? See, below the base of the footing you cannot go and take the soil sample, collect the soil sample and do it. However, above the footing you can always take the soil sample and check what is the value of gamma when the water table rises up. So either if you apply the RW1 factor in this equation also in Indian Standard Code, then ideally what you will be exactly doing, you will be ideally reducing the value of this gamma, right? You will be ideally reducing the value of this gamma. So if you reduce this value of gamma with RW1, that is perfectly okay. Or what you can do, you can use the exact value of unit weight of soil. So if the soil is submerged, you use in this place of gamma submerged. If the soil is saturated, you use gamma saturated. If the soil is having bulk unit weight, you use gamma bulk. Okay. So I think with this today's discussion we stop, and we have discussed everything about Indian Standard Code and 6403. Some more things are left, one or two things, we will discuss it in tomorrow's class, and we will try to finish up Indian Standard Code discussion tomorrow, and from the next week onwards we will move to consolidation. So if you have any doubt, any question, you can ask. Any question, any doubt?
Sir, sir, I have submitted the tomorrow Q's yesterday sir, which in bearing factor calculation from the Terzaghi's table. So can you open the form again so I can fill it again?
See, I haven't closed it. Okay, not a single.
Sir, but it is not reopening, sir.
Reopening because you have already submitted.
Yes, sir.
So what you do, if you want to resubmit it, what you do,
yes,
in the roll number, okay, roll number,
yes,
you give the same roll number, give the same
yes,
roll number, and then in front of the roll number, in front of the sorry, not in the front, at the end of the roll number you write 10. Are you getting? What is
Okay,
the
sir.
roll
Yes,
number?
sir.
So then you will be
49, sir.
then you will be able to
49.
insert. Then you will be able to insert. Means 1200 something you insert ना, then 49 के बाद और एक जीरो डाल के इंसर्ट कर दीजिए तो मेरे को समझ में आ जाएगा. ठीक है?
Okay,
Then
sir.
I will be getting
Yes,
two
sir.
answers from 49. I will be getting the next answer. I will be taking the
Yes,
next
sir.
answer. Okay. See,
Thank you,
don't worry about means this thing whether it is correct or wrong, but you should attempt it. Okay, you should try it. Okay, okay. So you resubmit, no problem. Okay, you give your roll number, because what I did, I just restricted for multiple entry, because many times people used to say with same roll number 5 times they used to enter. So it is very difficult for me what is the correct answer. Okay, so what you do,
Yes.
you just insert another one record, you enter it with your roll number, just at the behind you join a 0 and submit, no problem. Okay,
Okay. Yes, sir.
any other question? So should I stop? Okay, so tomorrow we'll discuss more about this bearing capacity.